In a research experiment, a population of fruit flies is doubling every 20 minutes. How many fruit flies will there be after 3.5 hours? So for this, our exponential growth basic model that we can use is a times b to the x. This works for pretty much every exponential growth problem. And we don't know the initial size, but what we can do is do this problem kind of in terms of the initial amount. So notice this question, it asks how many fruit flies will there be after 3.5 hours. We can't actually answer that perfectly because we don't know how many it starts with, but we can answer it relative to how much we started with. So what we do know is we're doubling every 20 minutes. That means if I plug in 20 minutes for x, I should end up with double of a. Okay, in other words, I should end up with 2a, since a is the initial amount, when I plug in 20 minutes. Okay. Now I need to remember that I am using minutes for x. All right, so x is measured in minutes. I'm just going to make a note of that so I remember. Okay, and now we can divide both sides by a, and it just cancels that out. So we have 2 is equal to b to the 20. And now to solve for b, we can raise both sides to the 1 over 20. And when we do that, it'll cancel that exponent. So we get 2 to the 1 over 20 for b. So our model, all we have for our model, we don't know a, but we do know b now. It's 2 to the 1 over 20. And if we take b and raise it to the x, we can go ahead and multiply those exponents. And so we get y equals a times 2 to the x over 20. This is as much as we can say about the model here. If we were told the initial size of this population, we would be able to plug that in for a. But let's go ahead and say what we can say about this. How many fruit flies will there be after 3.5 hours? So we need to get from hours to minutes, since I'm measuring things in minutes. So 3.5 hours. To convert to minutes, we know there are 60 minutes in an hour. And that'll cancel out hours for us, and that'll tell us how many minutes we have. And this ends up being, well, 3 times 60 is 180, and then plus another half of that, which is 30. So this is 210 minutes. And that's what we're plugging in now. So if we do that, we've got y equals a times 2 to the 210 over 20. And we don't really know what that number is, but let's go ahead and plug that into our calculator. So I'm going to go ahead and do 2 raised, oh, that's not what I wanted, 2 raised to the 210 over 20. And we get 1448.15. 1448.15, and that's, of course, times a. So essentially what we can say is after 3.5 hours, our population will be, 1,448 times the original size, which is pretty amazing, actually. And so that's what we can say. And of course, if we're told the initial size, we'd be able to give an exact number there.